A linear transformation is a function that maps vectors to vectors, preserving the operations of vector addition and scalar multiplication. In R², a linear transformation can be represented by a matrix. For example, consider the transformation defined by the matrix A, which is a 2 by 2 matrix. To apply this transformation to a vector, we multiply the matrix A by the vector. Let's use the vector v, which is represented as v equals x and y. The result of the transformation will be another vector, which we can denote as w. This is calculated as w equals a times v. Now let's work through an example. Let A be the matrix with entries 2, 1, 1, and 3. Let the vector v be 1 and 2. We can write this as v equals 1 and 2. Now we will calculate w by multiplying a and v. This involves taking the dot product of each row of A with the vector v. Calculating the first entry gives us 2 plus 2, which equals 4. The second entry gives us 1 plus 6, which equals 7. Thus, the transformed vector w is 4 and 7. This shows how the linear transformation changes the original vector. To check your understanding, consider what happens if you use a different vector v. How does the transformation change? In summary, linear transformations in R² can be easily computed using matrix multiplication, allowing us to transform vectors systematically.